Okay, so our book gives this really long, involved definition of the logarithmic function. A logarithm base b of a positive number x satisfies the following definition. For x greater than 0, b greater than 0, and b not 1, y is equal to the log base b of x and is equivalent to b to the y equals x. And then, of course, it describes how to read that. And, of course, I read it in the way that this is written right here. And the domain of the logarithm with base b is 0 to infinity, and its range with base b is all real numbers. Now, right now, you're probably not understanding what a logarithm is based on that definition. So let's go to some examples, and I'm going to show you a way to rewrite a logarithm so that it makes more sense what a logarithm is. So we're going to do some of these logarithms. And to do that, we're going to use kind of a circular pattern on every single one of them. So first of all, this little bitty number here is called the base. And this is my argument behind the logarithm. All right, and what we're going to do is we're going to take that little bitty base and we're going to rewrite this so that it doesn't contain a log at all. It's going to be 3 to the x equals 27. Notice that circular pattern. So 3 to the x equals 27. So notice that x, our answer to this, is an exponent. We want to know what power do I need to raise 3 to in order to get 27. Well, let's think about this. 3 times 3 is 9, and then 9 times another 3 is 27. So that's 3 3's that got multiplied, so it's 3 to the third. So x here is a third power. So really a logarithm is a way of finding a power. So let's do the same thing to the second one. We've got 2 raised to the x power equals 16. 2 to the x power equals 16. So let's think about what power do I need to raise 2 to? 2 times 2 is 4. That's 2 so far. Times 2 again is 8. Times 2 again is 16. That's 4 2's that we've multiplied. So x is 4. All right, well, let's look at this one. Again, let's use our circular rewrite now. 5 raised to the x equals 125. All right, so 5 to what power is going to give us 125? Well, if we do 5 times 5, that's 25. And then we multiply again by 5, that's 125. So that's 3 times that we multiplied the 5. 5 times 5 times 5. So x is 3. All right, now this next one is a little strange. We've got 2 to the x power equals this number. So 2 to the x power is 1 over 32. Now, I want you to imagine for a moment that instead of having that fraction there, we just had a 32 over on this side. Let's pretend for the moment that it's 2 to the x equals 32, and let's see what we would have if it was just 32 and not 1 over 32. Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32. So it would take 2 to the 5th power to get 32. And then what we have to remember from previous algebra classes is that what makes things into fraction form is a negative exponent. So it took the 5th power to get 32, but it's going to take a negative 5 power to put it into this fraction form. So anytime we're going from a base that's not a fraction into an answer that's a fraction, or vice versa, we want a negative power to make that change into fraction form. All right, now let's look at this one. 4 raised to the x equals 2. 4 to the x power equals 2. Now this one's really weird because we sit there and go, wait a minute, 2 is smaller than 4. 4 to some power equals 2. But let's go back to an idea that hopefully you have seen in previous algebra classes, but if not, we will get that idea here. The square root of 9 we know is 3, for example. Well, the square root is really the same thing as the 1/2 power. It's a fractional power, all right? So really this same equation right here can be written like that, all right? And if I had a cube root, that's a 1/3 power. And I have a fourth root, that's a 1/4 power. A fifth root, a 1/5 power. Now, usually in logarithms that we see in our class, we're only going to deal with probably a 1/2 power or a 1/3 power. But let's notice that if I took the square root of 4, I would get 2. So this is the square root, which is really the 1/2 power. So we have to be aware the square roots are also powers, and they are fractional powers, the 1/2 power. All right, now, on our calculator, we use logarithms, but there's only 2 buttons on our calculator, and they're buttons that are the most often occurring logarithms. The first one is the LOG button on your calculator, and you can look and find that now on your calculator. This is the common logarithm, and its base is 10. So if we see LOG with no base written, its base is 10. Because of course we are in a base 10 number system, so many of the logs that we deal with are base 10, since our number system itself is base 10. So if you see, for example, LOG 5, okay? Well, there's no base written there. That is base 10. And we can just immediately click on the LOG button on our calculator and put the 5 behind it and hit enter, and it tells us that that LOG log base 10 of 5 is 0.699 if I round to 3 decimal places. And you might try that on your calculator just to make sure that you're using your LOG button correctly. All right, on the other hand, we have a second button on the calculator called the natural log. The natural log has a base of E. And remember that E was that special number. It's an infinite decimal, but we round it off to 2.718. So when we see natural log, we will see that there's no base written there, but it's the only logarithm that has an ln as part of its symbols. So you know immediately this has a base of E. And we can, of course, find the natural log of 5 by hitting ln on our calculator, putting the 5 in, and then hitting enter. And, of course, it is a different answer because it's a different base. And that answer is 1.609. Now, these 2 buttons, LOG and LN, are the only ones in our calculator. So all these problems up here, we can't do in our calculator without having something else to do them with. All right, so since these 2 buttons are the only logarithms we have in our calculator, we use something called a change of base formula. So we can change any of the problems that we had up above into either the LN button or the LOG button. So let's notice, here's our formula, log base A of B. We use either the natural log button or the log button. But notice that this number that comes behind the log goes on top, and the number that is our little bitty base goes on the bottom. And we either use the ln or we use the log. Notice though, when you put it into the calculator, you've got to put it twice. You've got to click ln, whatever B is, divided by ln, whatever A is. All right, so let's do a few. And I want you to notice that on this one, for example, if I do that little circular rewrite that we did up above, if I do 7 raised to the x power equals 12, and I'll just put it over here because we're really going to see in a second that we can't really do this. All right, because 7 to the first is 7. 7 squared is 49. So how do we get 12? Well, it's got to be, the decimal's got to be somewhere between 1 and 2, because 7 to the first is 7 and 7 squared is 49, but we don't know what it is. We really need our calculator to tell us what it is. So that's where we're going to use this change of base formula. All right, so I'm going to just rewrite that log base 7 of 12, and it doesn't matter which button we decide to use. I'm just going to use the ln button. So we'll have ln of this number on top and ln of the little bitty base 7 on the bottom. And then we let our calculator do this. Now, I could have used this, but if I choose to use a log, I have to stick with a log on both the bottom and the top. And if I choose to use ln, I've got to stick with ln on both the bottom and the top. All right, so let me stick natural log of 12 divided by natural log of 7 on the into the calculator, and I get 1.277. I'm going to round to 3 decimal places. Now let me just note one thing. Most of your calculators are going to open a parenthesis when you hit natural log and you'll put your 12 in. Be sure to close that parenthesis before you hit your division symbol. And same thing on the bottom. You'll have it open that, you'll put your 7 in, and you'll have to close it. And it will naturally put that left side in. You just got to close the right side. All right? So let's do the same thing for this one. We'll find that if we do our little circular rewrite, we'll get something bizarre like this that doesn't work out perfectly. So let's instead use the change of base formula. This time, just to be different, I'll use the log button instead of the ln button. So I'll have log of the argument 54 over log of 3, the little bitty base, always on the bottom. And if I stick this into my calculator, it gives me 3.631. And there we have it.